Okay, there we go.
Yeah.
Soundboard's working. Okay, yay. Second time's a charm. Hopefully I don't have to do a third time. Windows just decided to shit the bed today, dude. Whatever. I'm getting rid of the music.
Gold.
What's up, brother?
Well, you know what my AP Lang teacher gave me for homework?
What? What did he give you?
She's making me read 33 pages and have to find 6 quotes and do like 3 sentences for each quote, like
Oh,
explaining
no,
it or
dude.
some shit. That was supposed to be all in one night, by the way.
33 pages is a lot. What are you reading 33 pages of?
Let me find the book, bro.
Okay. Go find it.
It's called The Joy Luck Club.
The Joy Lock Club. That sounds kind of cool.
It's about like Chinese immigrants or something like that.
Oh, wait, I've heard
Like
there's
English.
a movie. There's a movie on this, The Joy Luck Club. Joy Luck Club or something, right?
Yeah.
Called The
Well, I have
Joy
a day
Luck-
off tomorrow though.
Yeah, it's
Thank
President's.
God.
Is it President's Day or is that next week?
No, it's because it's a snow day.
Man, I think I had to read this too, honestly. Now that I think about it, or someone had to read it.
It's like from
What's up?
it's like
Ethan?
from the 70s, so
Is it
That's
Joy
like,
Luck
I-
Club?
1970, I think.
Yeah. What's up, Ethan? What's
Okay.
going on, dog?
I
What's up?
just took a test.
Yeah, Amy Tan.
Nice.
Amy Tan or whatever it's called.
Yeah, dude. How'd it go, dude? Ethan, how'd your test go? What's up, not your friend?
And I don't know how I did. Like,
Okay.
I really don't. I really wonder if I got a 90.
Well, I hope you did.
And I had to take a robotics test right after that.
That's a lot of stuff, dude. That's a lot of stuff you gotta do. All at
So,
once.
Ethan, what grade are you in?
But trust me,
He's in like 8th, I think, or 9th? 10th?
no,
Damn,
I
a
think
robotics
I'm
thing in
11th.
8?
No, I'm in 11th grade.
11th grade!
Oh. I was gonna say. Damn. Yo,
I
Ethan, you're
forgot.
smart either way.
Y'all have been here so many years, I can't even tell how old, like, any of you guys are anymore. I know when you started.
When did I start, huh? You know when I started?
Yeah, probably like 9th grade, right? 9th or 10th grade? Ethan, you've been here at least like 2 years, no?
Yeah.
Yeah, so I think
Yeah,
you
I've been here
started,
since
like-
2021. Damn.
Yeah. Obama's been here almost 3 years. Wow.
That's dope.
Since start of freshman year all the way to end.
Wow,
High
dude.
school.
Are you gonna be my first student that
That's
like
crazy.
starts high school and graduates high school? That would be crazy.
I know, that's crazy. Crazy thing.
That's crazy. What's up, Ethan?
So that's go.
Yes.
I don't have any math or science questions to ask today.
Oh,
If
that's
you could
good.
At least. Actually, hold on, wait.
Yeah,
Do you know
maybe it
T
does.
Kinter? You know T.
Do I know what? T what?
You know what? Do you know what's T Kinter?
Spell it out for me.
TKINTER.
No, I don't. T
Oh
Kinter?
dang. Well,
The hell?
it's like T Kinter. Yeah, it's like a programming language that's similar to Python. It has a Python
Oh.
programming language in it.
Okay, yeah. I mean, all programming languages are more or less the same. So
I have a word to do which I don't think you can understand.
I can understand many things. Just post a screenshot of it, and I'll get to it. Cool. Here, let me. I got to work through a lot of people's questions today, and I gotta teach another kid at like 5:30. So we got 2 hours and 15 minutes to stream today. Cool.
Oh wait, that's ago. I don't have it.
Okay. Well,
I-
find something similar. All
um
right, start off. All right, welcome everyone to Office Hours. My name is Dr. Gold Actual Education. The stream helps you out with math homework, science homework. What's up, Shifter? Good to see you. Yeah, been crazy weekend. Super Bowl was on Sunday. We had an awesome AMA on Friday. Who all came through to that? That was pretty fun, right? Had a good time.
Oh wait, that's ago. I just realized. Aren't you gonna do the spinner wheel thing for the second week?
No. Yeah, people think I give out $100 every fucking week. Dude. What? Like, no.
Stop it. Get some help.
That would be a lot of money. I don't have that.
True, but so when's the next giveaway then? For like a little mini giveaway.
April.
When's the
Well, okay, I may have a mini giveaway like, after a month or two. It depends what we get for gifts and stuff. But the big one's in April. I did the first week as a giveaway just so people could get an idea of, how the stream works, how to get points, how the tournament works. And we're adding more things. I just talked to a lot of the people that are like behind the scenes on what we're doing here, and we're we're going to have a lot more activities and challenges coming up. Which, yeah, maybe I'll put bonus prizes on those too. So, yeah.
We're done. All right then.
Cool. All right. Dope. All right. Let's see what we got for questions today. Got a lot of questions today. Dun, 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 dun. Help screenshots. First one I got up is Not Your Friend. What's up, Not Your Friend? Are you here? Yeah, I see you. You're in the chat. There you are. Yeah, what's up, Not Your Friend? Cool. All right. Let's see. We're going to be doing, what is a man in a boat? Okay. The mass of a boat is 300 kilograms, and the mass of the fisherman is 80. The boat is on fresh water. How much is the maximum mass of fish that the boat can hold without sinking? Oh, this is interesting. Doesn't this, like, depend on how big the boat is? Like, if this guy's on a cruise ship, right? You can do a lot. Let me think. The mass of the boat is 300. Is there not more information for this? Not Your Friend. Is this something from, like, yeah, do they give me the dimensions on this thing? Gotta have dimensions. Oh, the volume. There we go. Good. That's what I needed. Yes, yes. I'm like, this is the key bit information. Volume of boat. Yeah, it's okay. Is 4 cubic meters. Good. Yes. Because if this man's on a very big boat, things change. What's up? Who is that? Is that Anders? Dude, your text, your name is black. So, yeah, Anders. What's up, Anders? Because I use the dark theme on OBS, I can barely see your username on it. Yeah, it's okay. Okay. This is a cool thing. Yeah, this is called buoyancy. So did you learn this is this in your physics class you're learning this? There's a formula for this. Buoyancy formula. It's something about like the volume times the density has to be equal to, yeah, this is what it is. Archimedes formula. This is why things like float in water. And what it says is that the buoyant force is equal to the fluid density, so that's how dense the liquid is that you're in, times the gravity times g, which is acceleration due to gravity, times the volume of fluid that is displaced. So this is actually, here, let me get a picture of this. Got a picture of this, Archimedes. Andrews, do you do that on purpose to troll people, dude, so people can't see your username? Because almost everyone I know uses the dark theme, right? Man, all these graphics suck. Where's like a nice picture? I don't like this one either. Whatever. Okay, I kind of like this one. This one's okay. Just gotta make better pictures. Okay, cool. This is the principle. Yep. So, Not Your Friend. This is probably physics, right? Is this for a physics class? Because this is probably what you got, right? We got man on boat. They don't teach a formula, but they teach only the theory. Yeah, okay. Yeah, well, like the upthrust. Yeah, so here's what happens. Is the amount of liquid that is below the water line in whatever you're in, right? The amount of liquid that would be there. That's what we call like the volume. So here it is. It's force buoyancy is equal to negative rho GV. And then here, this V, this is the volume of like water that would be inside the thing if it were like submerged. So obviously in the boat, right? The maximum water that the boat could hold would be all the way up to the top, right? That's when you're like right about to completely sink. And so that's going to be the amount of volume that you could displace. So this is going to be 4. G is always 9.8. And then we got to figure out rho. Rho is the density of the fluid, which in this case is water. Although I get it seems that way. Japanese characters post black letters. Yeah, dude. I can. You want to see a screenshot of what I'm trying to see, Andrews? Here, I'm gonna show you to you. One sec. I'm gonna show him, dude. Like what I have to try to read. Although I know it's you now, Anders. I just always know it's you. But there you go, Anders. That's how you look in my OBS. It's not very easy to read it. Okay. Density of water. That's a good one to know. They ask us to get 10 as the G. That's fine. Yeah, we can use G equals 10. I know it's not the most accurate, but it's okay. We can use 10 here for it. That's fine. And then rho is the density of the liquid. So I think that's 998 kilograms per meters cubed. Density of water. What is it? Oh, 997. Okay. It's about 1,000. Okay, and your teacher, if she's using 10 for gravity, she's probably using 1,000 for rho. Okay, yeah, that's fine. Okay, this is 1,000. All right. So this is the maximum amount of buoyancy force that you could have from the water. It's maximum amount of like the water will push up on. So that's going to be, what is that? 40,000. So upwards, my buoyant force can be equal to 40,000 newtons. Okay? Yeah. What do I want to learn? Yeah, there's a lot, dude. Maybe, what are you doing in your class, Monkey? Go see what you're doing in class, and then that'll tell you. Okay, so 40,000 newtons is being pushed up. That tells me the maximum amount of weight from gravity I can have pushing down is also going to be 40,000 newtons. Okay? And let's remember that this weight going down, right? That's equal to mg. So I know that 40,000, which is the max, is going to equal to all the masses of the things here. So I have the boat. The boat's at least 300, right? The fisherman is 80. And then we have the fish. The maximum amount of fish. And then, so this is all of the mass. And then we got to multiply this by g, which is 10. Okay? So now I get that 4,000 is equal to, I'm just going to divide the 10 out here on both sides. Okay, so this goes away. So 4,000 is equal to 380 plus the fish. Wow, that's a lot of fish you can bring, right? Because if I just minus 380 from this, right? Okay. That's going to be 3,620 kilograms of fish. So that's the additional weight you can take. Wow, that's a lot. I guess this is kind of a big boat, like 4 meters cubed. 4 cubic meters is a lot. Yeah, right? 4,010, yeah, equals mg. 4,000 equals m. Yeah, that's a lot of fish. Yeah. Here, I'll download this for you. But does that make sense? Not your friend? Make a little bit more sense? Cool. Nice. Good job, dude.
Well done! Well done!
Good stuff, dude. Cool. Let me add that in. No. Dun, 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 dun. Oh, and yeah, we're gonna get you the weekly question roll for today. Nice, good stuff. All right, Mikasa. Mikasa, where you at? Got a question for you here, Mikasa. If Mikasa's not here, then I'll move on to Equity. So let's see, let's tag him. Mikasa, Equity. And we'll wait a little bit.
What are you doing? What are you doing?
You give him like, 20, 30 seconds to hop in.
Just hanging around.
You have a physics question,
What are you
Anders?
doing?
That's dope. Can you post a screenshot in our Discord?
What are you doing?
Makes it easy. Oh, Equity's here. Nice, good, cool. All right. All right, Equity, let's do yours. Beetlejuice? I don't know how to spell. Yeah. Okay. Yeah, I added some more fun stuff to the stream here for you guys. I was inspired by Penn Center. Penn Center honestly inspired me to like step up some stuff on the stream. The question, you didn't ask a question last week, Nick. You just gave me a bunch of random calculus identities. Jamarcus, post a screenshot of what you said. Again, that's the only way I keep up with it. Okay, Equity, here. Find the equation in slope-intercept form of a line that is the perpendicular bisector of segment AB with endpoints -5, 5 and 3, -3. Ooh. Equity, do you know what a perpendicular bisector is? This is review, so okay. Review means you know it, right? Or you don't know it yet. You need a refresher. That's okay. Yeah, okay, cool. All right, first thing to do is like the plot, like what the point is, like -5, 5. That's got to be like something over here, right? And then B is 3 -3, so that's like right here. Okay, cool. All right, and so then this makes a line, right? Like this. Is it a line in the middle of the segment? Yes.
Nice.
It is. And what makes it unique is that it's perpendicular to that line. So the perpendicular bisector, not only does it cut this in what we say cut it in half, but it's also got to be 90 to this line. Yeah. So it's got to be 90 degrees. It's got to be perpendicular to it, and it's also got to hit it right at the center. All right. So the general strat of how to do this is you got to figure out first off, like, what point does this perpendicular bisector go through, right? Which we know needs to be the midpoint of these two things. And then once I know that, I need to know what the slope is, right? In order to find the equation of a line, I need a point that it's on and the slope. Or, right, 2 points gets me a slope, whatever. But yeah. Twitch is bugging? What's wrong with Twitch? Oh. Twitch is Twitch bugging? Is Discord okay? I think everyone else is okay with Discord. You tell me what's happening. Refresh? Yeah, Bob says refresh. Yeah, refresh your page. Yeah. Okay, cool. All right. So yeah, equity, the strategy again, sorry. So for a line, I need 1 point at least and a slope. Okay? So, what's up, Mikasa? I'll do your question next, Mikasa. I appreciate you coming by. So I need this point, and then I need the slope. And what I know is that if this is the perpendicular line, you should remember how to find the slope of a perpendicular line to another line. Like, if I know the slope of this, I can figure out what the perpendicular slope is. Okay, so first thing I need to do is I need to find the midpoint. Negative reciprocal. Exactly. Yes, very good. Yeah, so let's find the midpoint. Do you remember how to find the midpoint between these 2 points? There's like an equation for it. It's like x1 plus x2 all over 2, comma, y1 plus y2 all over 2. It's still not working? What happened to Twitch? Anybody else in Twitch, you tell me if it's not working. I think it is. Nick, you can make me check this? I'm going to check this, dude. What's going on? Dude, what's going on? Yeah, it's fine. Twitch is fine. Yeah, I just checked it on myself. Yeah. All right, so to find the midpoint here, we gotta average the x's, right? So I have a -5 from this x and a 3 from this x. So that's -5 plus 3 all over 2. And then we gotta average the y's, which is a +5 minus 3 all over 2. Okay? This is going to become -2 over 2, which is just -1. And then this is going to become 2 over 2, which is just 1. And we should be able to like visually see that makes sense, right? So, what do we say it was? -1, comma 1. Yeah, look. -1, comma 1 is right here. That looks like it's probably the midpoint.
Oh, yeah.
So we're probably in the right spot. Last thing we got to do is we got to find out what this slope is by finding the perpendiculars. Thank you, Mondo, dude. What's up, Mondo, dude? Thank you, dude. Good to see you, Mondo. Yeah, so the slope of this thing, right, is this is just y minus y over x minus x. So we got 2 points here. So we got -3 minus 5. I'm going to do this one minus this one, all over this one minus this one. So that's going to be 3 minus -5, right? So that's going to be becoming -8 over 8. So that slope is -1. And that kind of makes sense, Equity. Do you see how this line looks like it goes down with a slope of -1? Okay. So if this slope is -1, what's the slope of the perpendicular line to it? What's the slope of this bad boy? Go, what happened to Jack? We do need him. 1/2, close. Okay, so let's remember. It's the negative reciprocal. So -1 is the same thing as like -1 over 1. So if I flip that, Equity, right? and I make that negative, that's just going to be positive 1 over 1, which is still just 1. Oh, bruh, 1 here. That's okay, good. Cool. So, I know the slope is equal to 1. I know the point is -1, comma 1. What format do they want this shit in? Slope-intercept form. Okay, so that's not too bad. Do you remember how to get an equation of a line in slope-intercept once you have a slope and a point? We could actually do it by just looking at it, too, if we really wanted to. One equals 1 plus b. Good, yeah. So, yeah, y is equal to mx plus b. You know this slope is 1. So, yeah, good. Plug in the point to figure out what b is. And when you do that, you get 1 is equal to 1 times minus 1 plus b. So, in that case, b has to be equal to 2, right? And then you have your final equation, which is y is equal to 1x minus plus 2, which you can just drop this, and it's just y is equal to x plus 2. There you go. Good job. Yeah, you're welcome, dude.
Well done.
Nice. Okay, cool. Weekly question. Good. Nice. And here, I'll get you a copy of this one so you can see it. Equity. Is this for your test coming up? You got a test? You got a test? The other one they could ask you is like parallel through this, but yeah. Yeah, again, perpendicular bisector, halfway, perpendicular. At the end of the unit. Okay, all good. All right, Mikasa. What's up, Mikasa? Do you want to come speak? You can speak in the chat. You can speak in the voice. I don't care. Whatever you want to do. I always like shoot an invite out. That y equals mx plus b, baby. Yeah, you know what it's about. Y equals mx plus b, baby. Let's see. Where's Mikasa? Well, oh, Mikasa also uploaded like a super high resolution one or something. Gold, at the end of the stream, can you check the vid I sent in office hours? Yeah, if I have time, I'll go to it. There's a lot of things going on. What's up, Abams?
It takes so long to load.
Well, it's because it's a very high resolution image. Like, I guarantee this is like a very, very big image. Whoever.
Whose is it?
It's Mikasa's. It'll load eventually. This is probably like, there we go. See, the reason why it took so long to, yeah, like because I can like zoom right into like the individual pixels. It's okay.
Damn.
Okay. Mikasa, which one you need help with? What's up, Mikasa? I said, yeah. There you go. I gave you permission to speak. Yeah, there we go. What's up, Mikasa?
Thing was lagging. Hey,
Oh, it's
how
all
are
good.
you?
Good. How's life? How's the other side of the pond?
Yeah, pretty good. Not too bad so far.
Not too bad. Not too cheeky.
And yeah, I need help on question 5.
Okay. Find the volume of a solid obtained by rotating the region bounded by the curve, the line, and the y-axis. I love these. These are great. Yeah. I know. Some people hate them. They're just like no, I don't want to do this. Like, God, don't do it. But it's not that bad. Okay, so... Okay, about the y... I like to draw this out first, just to kind of like see what we got, right? So, we're going to rotate around this axis, right? And we got to find... So, okay. That's going to be this. And it's bounded by the curve y equals x. So, that's going to be this already, right? Y equals x. The line x equals 3y. Ew. Can we just call this like y equals x over 3? It's kind of weird why they said that, right? I would just say y is equal to x over 3. But whatever. So that looks something like this, right?
Yeah.
And the y-axis. Wait, but this is the y-axis. What? Excuse me?
About the y-axis. So
Oh, okay. Wait.
it's
Sorry.
a different
Bound.
formula.
Yeah, y equals x. X equals 3y. About the y-axis. But wait, where does it stop? right? It has to intersect somewhere. Usually, right, we have something like
don't
this. Usually we have something like this, and then I rotate this around, right? So it makes like kind of like
Yeah.
a cube or something. This is like unbounded. This
Yeah,
just
that-
keeps going.
I was exactly. There's no limits.
Yeah, there are no limits.
My professor told me to like equate them together to find the limits, but then you can't equate them together because
Well, they
just
do.
separate.
Well, no, you can't equate them together, but it's at 0. Right? Like these things are both solutions when x and y are equal to 0. This is a
I'm
very
just confused
very-
as how they got an answer because it says over there the answer is 162 pi over.
Yeah, no, there's a typo here. There's got to be a typo. Yeah. I mean, let me see. Maybe. Well. Let me Google this. Let me see if there's a similar, and he just like forgot to write some of the text. Because if I put this question into Google like with the answer, it may like have what the correct question was supposed to be. Find the volume of the solid obtained, and then it was y is equal to x. I think they meant to say x equals 3. Yeah, can we just assume that? I think that's actually what happens. Well, but he said, oh, make them equal to each other, but no.
Three.
Yeah, I think if x equals 3, we're actually probably going to get a good number. X equals 3. Or x, because, yeah, he shouldn't have said x equals 3y. And also, remember I said that was weird? I'm like, why is he not just saying y equals x over 3? I think he, like, mistyped that. And then, let's see, 162.
Yeah.
Yeah. Okay. We'll see if we get the right answer, but I'm assuming this should be x is equal to 3, is what it is. Because then this is what he's talking about when he talks about the equating, right? If I go over here to 3, then this is going to be something, right? And now I have... But then also, he should have said also bounded by the x-axis, which he didn't say either. Ugh! This man... I hate when people do this.
Very confusing.
Well, he's just wrong. I mean, he's just, your teacher's just like not putting. Okay, let me say. Well, we're not going to get the right answer, but tell him he's wrong here because what this should say, for instance, let's say this was y was equal to x squared. That's usually what I would say, and where I would have something like this. Okay. Because I need it to be bounded on two ends, right? I need it to be bounded here and here.
Mm-hmm.
Okay? And then I have a cross section which will be rotated around. When he's just saying like, "Oh, if it's just this, well, you also, buddy, you need to tell me this is bounding." And if it's just this doesn't intersect anywhere. So it just doesn't work. Yeah. So, let's assume it's this, okay? Do you know how to do it if it's this?
Yeah.
Yeah? You sure? I mean, I can go through it. It's not too bad, right? Okay. Well, here, let me just do it. Let's assume this is y is equal to x squared.
You equate them together. You find.
Mm-hmm.
Mm-hmm.
So you set them equal. You set them where they intersect, right? So they intersect here, right, at 0, 0. And then if I set these equal to each other up here, right, this is also at 1, 1, right?
Wait, what?
Yeah, watch. Okay.
Wait.
Set these equal to each other.
When you set them equal to each other,
Mm-hmm.
x equals x squared.
Good. So
Okay, but then
divide by x,
value
divide by
is
x. 1 is equal to x,
Oh right, yeah.
right?
Sorry, I had visualization problem.
Yes. Well, it's okay. And again, you don't need to be able to draw things in order to do this type of question. You just need to be able to figure out the endpoints of like where these two intersect, which means you set them equal to each other. And x is equal to x squared, right? Whenever you divide by x, you need to check to make sure what would happen if x was equal to 0. Because that solution gets lost when we do this. You see how I would technically only get one solution here? X is equal to 1. But in reality, 0 also equals 0 squared. Yeah. So just a little like, this is a tip for future problems, Mikasa, is that if anytime you're dividing by something, make sure you're not excluding the solution where the thing you divided by could be 0. Okay. Okay. So once you have this and this, I like to set up an integral, right? And then I like to say like d something, which is like what axis are we like traveling along? Which is usually what is the axis that it's being rotated around. So since this is being rotated around the y-axis, I know this is going to be dy.
Yeah.
And I know we have to travel. So then I say, okay, cool, but what y points am I traveling from? In this case, we're traveling from y equals 0 all the way up to y equals 1, right?
Yeah.
Good. So I'm going 0, 1. And then this is a pi on the outside. And then what it is it's like r outer squared minus r inner squared dy. So this is like pi r squared. Yeah, so outer means so look. So when I'm building like my disks, right? This is, for instance, r outer, okay? But then we got to subtract that from the disk that's right here, because this is going to be r inner in order to get like this in between like donut.
Yeah, I see it.
Right? Okay.
And is that because there's like, is that because we have two curves?
Yes, because you have two curves.
One curve in the line.
Exactly. Yes. So
Yeah,
in this case, yeah, r outer, right? But then I need an equation for like what this radius is in terms of this variable, in terms of y, right? So here, right, this curve, right, how far I am from my axis of rotation, that's what I call is like the x coordinate, right? And the x coordinate of the curve y equals x squared is equal to the square root of y. So wherever I am on this curve, right, whatever my y position is on the curve, my x coordinate is the square root of that. Because y is equal to x squared, right? So x is equal to square root of y. Do you see that? That's a tricky thing that's tricky to get. Let me like zoom in a little bit on this. Oh, what happened to Mikasa? Oh, Mikasa's disconnected. No, come back, Mikasa. Come back. Oh, there he is. One second, I'll get you back on. There we go. All right, what's up, Mikasa? Yeah, you good?
It's okay. You're connecting all the way from the UK. Internet can be kind of hard sometimes, right? Anyways, because
could you go over that bit again?
Let me do it again. Okay. All right. So let's we see here, right? I'm trying to get this radius, right? Okay.
Yeah.
Notice how that radius is going to change based on where
along the purple curve I am, okay? So see here, like as I go along this purple curve, this distance is going to change, okay? And the value of this distance, right? Like let's say this is at some just coordinate, x1 comma y1, right?
Yeah.
This distance here is just what the x coordinate is. It's just what x is for that curve. And that curve is y is equal to x squared. So this is the relationship between the x coordinate and the y coordinate. It says that the y coordinate is always whatever the x coordinate is squared.
Yeah.
You see that? Right? So that means the x coordinate is always whatever the y coordinate is, but the square root of it. Right? Y equals x squared is the same thing as x is equal to the square root of y. Technically it's plus or minus, but whatever. We're taking the positive one. Right? Okay.
Yeah, I can see that.
Right? So when I think about r outer, right, the outermost radius, which is described by this purple U-shaped curve, that I'm going to put as
Yeah.
the square root of y. Okay?
Yeah.
I'm not going to put x squared because notice how my integral is in terms of dy. If I start putting x's here when I have dy's, like, it doesn't work. Like, you can't do those
Mhm.
integrals. Okay? All right.
Yeah.
What am I going to put for our inner then? What's our inner going to be?
X equal just y.
Yeah, it's just going to be y.
Y squared.
It's just going to be, yeah, exactly. This is just going to become y squared, right?
Yeah.
Because for this curve, right, it's just y equals equal to x. So whatever the x curve is whatever the y curve is.
Yeah. That one's
Yeah.
pretty easy.
That one's pretty easy, yeah. Where this can start to get more complicated, and then what? And then we're basically done. This is a simple integral to do, right? Because this is just pi times integral
it's
from
just-
0 to 1 of y minus integral from 0 to 1 of y squared.
Yeah.
Simple. You know how to do that. Yeah. Okay. Where this will sometimes get tricky here, Mikasa, is they won't rotate it around the y-axis. They'll say, let's rotate it around, for instance, y is equal to -4. Like, they'll do this.
Uh,
They'll say, or like y is equal to -1. And they'll say, hey, we're rotating it around here. Okay?
oh wow.
Yeah, yeah. It's not that bad. All it does is it changes what you're going to write for R0. Because now R0, right, is not just going to be the x coordinate. It's going to be whatever the x coordinate is plus 1. Do you see that?
Okay. I think so. Yeah.
Yeah. So don't get scared whenever they do this. Like, I also see the classic one of, like, it's up here, and then they're rotating it about something up here. And then, I don't know, say, like, this is the curve, right? And then you have to be like, okay, cool. Well, I need this, right? This is like let's just say it's a single curve, and it's rotating around this. Like, let's say this is y is equal to 3. Then whatever this r is, right? This ends up being 3 minus whatever the y coordinate is for this. Okay?
Yeah.
So let's say we were rotating around this. So since we're rotating around like a horizontal line, our integral ends up being like pi, and then it's like r squared dx, because we're going from here to here, building a bunch of loops.
Mm-hmm.
And then this radius, let's say this curve was y is equal to what would that be, like x minus 5 squared plus 2 or something. Yeah, that's like something here shifted to the right and shifted up a little bit. Your radius here then becomes 3 minus this whole thing, x minus 5 squared plus 2. This whole thing ends up becoming r. Because the y coordinate of this curve describes this distance, but I need to know this distance, which is 3 minus this distance. Do you see
I
that?
see.
Yeah.
Yeah.
That's just like, that's the next thing they're going to ask you on it. I guarantee you. That's the next. They're going to move the rotation from one of the axes, and they're going to put it on something else.
Mm. It's
Cool.
got one more question.
What's up?
It's related. So how come we're multiplying by pi instead of 2 pi, since 2
Okay.
pi is usually like a full circle, a revolution, whatnot?
So, depends if we're doing, they call this, I think it's like shells versus something. What do they call it? Washers and shells or something? What do they call it? I forgot. Well, okay. So it's pi r squared because that's the area of a circle. Okay.
Mhm.
2 pi r, that's equal to the circumference. Okay. If you're trying to
Yeah.
find the surface area of a solid of revolution, you only care about this outside bit, right?
Yeah.
That's why you use the circumference, because you're just adding the 2 pi r of all these circles as you go along. If I want the volume, then I care about all the stuff inside of it. And that's where I need to use the area of a circle, which is pi r squared. Does that make sense?
Alright, yeah. Yeah.
So when they say surface area, yeah, you usually use 2 pi r because that only catches the outside lip. And then pi r
Yeah.
squared catches the whole volume.
Mm-hmm.
Nice.
Okay.
These are good questions, man. But yeah, go to your teacher and tell him like this is wrong. Like, did I be like, yeah, no, dude.
Yeah.
It's just it's not.
Teacher had me
This
fucking-
piece of shit.
Yeah, dude. Yeah, you can't do that. Guys, thank you. Okay, cool. Awesome. Good job, Mikasa. Great question. Yeah.
Thank you.
Yeah, you're welcome, dude. Nice. All right, Obama. Where's Obama? One sec. Where's Obama, dude? Obama, where you at, dude? Obama, my boy. Drink your water, dude. Thank you. I do need to hydrate.
No.
Yeah, what's up, Obama? I dehydrated myself a lot on the Super Bowl, so I appreciate that, Zach. I really do. Oh, thank you, Zach, for getting back to me with... I'm going to respond to all the other math streamers. Thank you guys for getting back to me in Penn Center's server about letting the students ask questions on your streams, too. I'm really thankful for that, yeah, because we're hitting a lot of questions here. And, you know, I want it to spread out. I want other streamers to get involved, and I want students to know that there's other places you can get help. Like, it's not just here. The Golden Flask. One of my students actually bought this for me as like a Christmas gift or something. I'm very easy to buy gifts for. It's just like, what color is it? All right, Obama. What is up? We're doing sine and cosine?
Wait, was it Sam?
This is Sam? Who's Sam? Oh, did Sam buy me the gift? No, it's a different Sam.
Yeah.
No, not Sam.
I thought it was him.
I still haven't seen Sam.
Really? I thought you guys did.
Sam lives down the street from me, but I've never seen Sam in person.
Oh.
It's too funny. I will eventually at some point. Okay, what's up? So, you have to simplify that? Is this what this is, right?
Yep.
So this looks like kind of complicated, right? You're like, oh god, we got tangents and cosecants and all that stuff.
Yeah.
Okay. The way to do this is to always convert everything into just sine and cosine. That's the trick, okay? Do you know how to convert tangent into sine and cosine?
Yeah, tangent is sine over cosine, right?
Nice.
Yeah, that's good. Tangent is equal to sine of cosine. Love that. Okay. What is cosecant?
1 over sine.
Very good. Okay. So you
And
see
then
how
another one, right? Because it's squared.
no.
wait.
This is just a 2. This is just a 2 times it. Yeah.
Oh my god, for real?
If it was cosecant squared, you're right. But it's not. It's just they're just multiplying 2 on there. That's all they're doing.
Oh.
Okay. So this ends up being sine over cosine, right? Times, and then this is 2 over sine, right? Because it's 2 times 1 over sine. And then it's over sine over cosine. Well, this is kind of silly, though, right? Because, look, the tangent and tangent, these things are just going to cancel. Right? If you're multiplying by tangent and then dividing by tangent, right? Same thing?
Yeah.
Yeah. So this goes away. And you're just left with 2 over sine, which, yeah, is just 2 cosecant. You didn't have to go that far. That's actually easy. Give me a harder one, Obama. This is
Are you
easy.
being for real?
Yeah, dude, this is just 2 cosecant, bro. This one's way too easy. Dude, what?
Yo, I think I just overthought that one, bro.
Yeah, no.
Yo, I have like a whole list of me just trying to solve it because I thought it was what's called squaring.
No. One sec. Hard trig identity problems. I'm just gonna get you one.
Okay. You're not too hard, bro. I just learned this today.
This is not too hard. Okay, what was it? Trig identity problem. Yeah, that's one with that's with. Dude, where's just like a sheet of these things, dude? Yeah, I like these. These are cool.
Like, you should put a challenge problem, but I don't know if it's hard.
Oh well,
It's
yeah,
sine
post it.
Plus
What is it?
cosine and then times cotangent, but I don't know if that's hard.
All right, one second. Let me pull it up.
Bro, you have to put mild, medium, and spicy as like the names of each problem.
Mild, medium, or
Because
spicy.
my whole class
dude?
is dumb.
What? Mild, medium,
Yeah.
medium, or spicy, dude? What? Okay. One
Like,
second.
mild, easy, medium, like it's okay.
Okay, what was the
Spicy's, like,
spicy?
actually
What
hard.
was the spicy question? I agree, Zach.
It was
What does it
sine
simplify?
plus cosine
Sine of x plus
times
cosine.
cotangent.
All of this times cotangent, or just the cosine?
Yeah. But well, hold on. Let me write it in the thing, cause.
Okay.
It's on.
I agree, Zach. Yeah. So usually they'll say like, yeah, simplify is like beauty's in the eye of the beholder, right? Like some people don't like fractions. Some people don't like this. Some people just hate cosecant. It's sine. Okay, cosecant, cotangent. Okay, so they're saying this. So they're saying sine of x plus cosine of x cotangent of x.
Yeah.
Treat as this optimization. You're trying to minimize the amount of characters? Yeah, I guess so. Usually they'll say show that this equals this, and you can either take the left side, make it look like the right, or make the right side look like the left. And like sometimes one is easier than the other. Okay. Well, okay, this isn't too bad. So what is cotangent? How do I write that?
Hold up. Let me see. Cosine over sine.
Good, exactly. Yeah, this is just cosine over sine. Okay. Okay. All right. Now, this looks like a fraction, and this is kind of also a fraction. How do I combine these two fractions? What do they have to have?
What? Wait, what do you mean?
Like, if I wanted to add, I don't know, a third plus a fourth, right? How do I add these fractions? What do I got to do to them?
Espera.
Espera. ¿Qué necesitas hacer para simplificar esta expresión?
Hold up. She wants me to do laundry.
Laundry?
Like real quick.
Oh, just tell
Yeah,
me.
it takes me like 2 minutes to get down and put it, but.
Okay, tell her you need like 20 seconds for this. Just real quick. It's very easy.
Espera, un poco. Yo voy a bajar rapidito.
Yeah,
¿Cuánto
so-
tiempo?
Yeah, tell her you're...
No más que la camisa. Jabón
Don't make her get the chanclas out, though, dude.
toda la bañera.
She's gonna show the chanclas at you.
Primero las monedas.
Ajá.
Después el jabón regado por toda la lavadora. Y
Ajá.
después ya echa la ropa.
¿Qué? Dígame dónde está.
Entonces ya si te tiene que bajar.
Okay.
Did Mama
Oh
throw
my
the
Lord,
chanclas?
bro.
Did she throw the chanclas at you, or do we get like 30 more seconds to teach you trick?
A little, cause she gets mad. I don't know. She
Okay.
makes me do laundry and everything. So.
That's okay. Your mom loves you if she's making you do laundry. Like that's good. It's a good thing. Anyways, okay. We're almost done here. These need to have the same denominator, Obama, right? Okay.
Yeah.
What do you see how this has a sign and this has a 1 on it? How do I make this have the same
Yeah.
denominator as this? What do I do?
Can you put a sign there?
Yeah, good. So let me multiply the top and bottom both by sign. You can't just put it there, right? You have to multiply the top and the bottom by the same thing.
Mm-hmm.
Okay. So I get sine times sine. The other way we write this, Obama, this is sine squared of x. Okay. Over sine of x. And then cosine times cosine is cosine squared of x over sine of x.
Mm-hmm.
Make sense so far?
Yeah.
Okay. Now these have the same denominators. I can combine them. So this is sine squared of x plus cosine squared of x all over a single thing, sine of x. Do you know what this is? Sine squared plus cosine squared?
I know. It's like an identity or some shit, bro. What's it called? A Pythagorean
No,
identity, right?
I don't know what they
Is it
actually
not?
call it. It is. It's called some sort of identity. I don't know what the actual name for it is. It's just equal to
Yeah,
1.
it's Pythagorean, I think. It's equal to 1, right?
This is equal to 1. Good. So this is 1 over
Yeah,
sine of
that's
x. Okay. And then what's 1 over sine of x?
Cosecant.
Cosecant of x. Yes, good job. Nice.
That's dope.
Good job.
I have to go.
All right, yeah, go do your laundry before don't let Mama throw the chanclas at you. I'll send this to
Yeah.
you. I'll send this to you so you get credit. But yeah, good job, man. Good job.
All right.
All right, peace, dude.
Bye. Well, I'm just deafened. Well, whatever.
All right, you're good. Whatever you want to do, you're good. Olaf, yes, we have Olaf. Yeah. Let me get him. That was a good one. I have this thing, Zach, dude. It's too funny, man. Like, parents don't understand what's happening. They think their kid's just like watching Twitch and just, I don't know, looking at some gamer kid playing Fortnite or something. I'm like, no, I'm trying to like teach your son math, or like I'm trying to give them free help that you probably like could not afford. Like, can you please let your kid just do this? But they just don't think that's the case. What's up, Teacup? Your teacher wants you. My parents suggest I take Algebra 2 instead of Algebra 2 Trig. What's the difference there? What? You mean Algebra 2 and Trig concurrently, or is it like a combined class? They should just put you into calculus. Honestly, is what they should do. You want me to call your parents? I'll call your parents, dude. Nice, Obama. Very good. I should stream Fortnite instead of math. I mean, you know, you get the kids involved, but I don't know. OOT. What's OOT? Out of time? What is OOT? Ooh, Ocarina of Time. Yeah, aren't y'all speedrunning that? I thought y'all were doing a speedrun. Y'all speedrunning Ocarina of Time, right? Yeah, check out... Yeah, if any of you guys like classic video games, I know some of you like probably too young to know what an N64 is, but we got some awesome math streamers here. Which one do I have for you? I think it's EXP2i Pi. Did I write that right? There you go. Yeah, that's his Twitch. You're gonna stream Ocarina of Time 100%, and if I get hit, then do maths tonight. Okay, cool. Yeah. So EXP, you've done some Ocarina of Time things before, and then yeah, the other one is. Were you streaming today, Pen Center? I think you were, right? Yeah, there's Pen Center's stream. He's doing a very cool thing. He's doing a was it 100 integrals challenge or something? Yeah, 100 integrals. Oh, we're on to part 3 now. Wow. Okay, cool. Oh, was this when you were like getting mad at Elgato? Yeah. So yeah, if you want to see some really cool techniques for like solving difficult integrals, Pen Center's going through 100 of them for the next couple streams. 26 out of 100. I think I submitted one to you actually. And it's funny, the one I submitted, it's from a student that I was teaching who's going to like University of Tel Aviv and has like the most god-awful teacher that just asks ridiculously hard questions out of an intro calc class. And I remember getting one of those integrals. I'm like, I'm gonna send this one to Pen Center. Yeah, second half of the 100. You'll be back, Nick. Okay, cool. Anyways, yeah, check out their streams. They're awesome as well. Love what you guys do. What's up? Next up we got Deba. Okay, cool, dude. What's up, Deba? Deba posted, this is a question. I'm gonna make it harder for you, Deba, though, because like I think you know how to do this one. Deba, do you know how to do this one? I'm pretty sure you know how to do this. 12x equals 252. What grade are you in, Deba? I almost gave you integral of dx over x squared, x to the 6 minus 1. Wait, isn't that's got to be something with like arctangent or something, right? I almost see a difference of cubes or difference of squares. Deba says he's in 7th grade. Okay, that's cool, Deba. All right. Do you know how to do this one? I mean, this is not too bad. It's part of your homework. Okay. Yeah, it's the difference of squares and cubes, yeah. And there must be an arctangent in there somewhere then. Or arcsecant. Deba says, yeah, okay, cool. Is it x is equal to 252 divided by 12? Yes, yeah. Anytime you see something like this, yeah, this is just divide by 12. Divide by 12. This is not too bad, right? This ends up being, I think this is 21. Probably 21. Yeah. Because 2 times 12 is 24, plus another 1.2. Yeah, 25.2. Yeah. Yeah, this isn't too bad. This is just 21. Okay, Deba, let's make it a little bit more challenging for you, though. Here, I'm gonna make it stuff a little bit more fun. equal to negative 120. How do we do this one, Diba? Make it a little bit more challenging. Yeah, partial fractions, that would be nuts. No, the Lambert functions? No, you guys gotta stop with that. Diba, how do we do this one? You knew how to do this one, which is pretty easy. But let's make it a little bit tougher. A little bit trickier. What's up, Lagar's 15? Is the answer 15? I don't think the answer is 15. Is it? Maybe it is. Mm-hmm. You don't know. Okay. Well then, yeah, well, that's why you're here. Let me teach you. Okay. What I always like to do in algebra, Diba, if I'm trying to solve, this is algebra. Algebra means you're trying to solve for like what this variable is. You're trying to get this thing. And the whole goal of algebra is to get this by itself and then a bunch of whatever on the other side. Numbers, hopefully a single number, right? Okay. I always like to look at what is happening to this thing and then like kind of work out from the furthest thing towards the closest thing. Okay? So, when I look at x, which is what I'm looking for, what thing on this side is happening to x that's like the furthest away? Like what number here is like doing something that's the furthest away? The 5? I agree. Okay. And what is the 5 doing? Like, is it adding? Is it subtracting? Okay. Well, let's look. Whenever you have a 5 outside of a parentheses right here, right? What is that doing? If I have, like, for instance, like, I don't know, like 6 parentheses 2, right? How do I evaluate that, Diba? What does the 6 and the 2 do to each other? Hey, what's up, Ian Stucky? In the house, dude. How are you streaming, Ian Stucky? Good morning, gamers. Nice, that's great. Lovely stream. We love lovely streams. Hell yeah, dude. Glad to have you in Stucky. Glad you're having a lovely stream. Lovely Monday. Yes, dude. Oh, and we got some follows. What's up, Patty Moon? Thank you, man. Appreciate that. Yeah, Diba, this is multiplying by this, right? And so what I always like to do is like the opposite of multiplying, which is to divide by. Nice raid animation. Yeah, thanks, dude.
Yes, okay. So, the opposite of multiplying is dividing. So I'm going to divide both sides here, Diva, by 5. Okay? And what that's going to do is that's going to get rid of these things right here. Away they go, right? So now, I'm going to be left with 3 minus 9x is equal to negative 120 over 5. Which you may need a calculator for this. I know what the answer is, but this is going to end up being negative 24. Okay.
What's the other next closest thing that's happening to this x here, this 9x? Please enjoy Baby Gold. Yeah, my voice is already super high pitched, so like I don't know how much more that this filter can really do. It is fun though. Please enjoy baby gold. Yeah. Courtesy. Yeah. All right, Diva. So, the next closest thing to this X here is this 3. See the 3 here, right? It's typing. Which I would say is being added to 9x. I know that doesn't look obvious. To you, you see the subtraction and you're like, wait a minute, aren't they subtracting each other? Well, technically, the 9x is being subtracted from 3. Another way to write this is to kind of just like flip the positions. So maybe if this sometimes makes it look easier to students. I say this is equal to negative 24, all right? So anytime you have, for instance, this is a good thing for everyone else here in math. If you have a minus b, this is the same thing as negative b plus a. Sometimes I'll just like put the plus here, and I'm just like, all right, cool, let's just like move it over, right? You can do this. And that's technically the same expression. So this is an important thing to know in like basic algebra stuff. I like didn't know that for the longest time. It messed me up. But if we do that with here, right? If I pretend there's a plus here, and then I move this whole thing over here, right? So that it's now negative 9x plus 3. You now see that the next furthest thing away from the x is adding 3. And the opposite of addition is subtraction. So we're going to minus 3. And now this is going to go away. This is going to become minus 27. And I'm going to have negative 9x is equal to negative 27. Okay? Now, Diva, for the last step, I know you can do this because you did it in the last one. What's the last thing I need to do here to solve for x? What's the last thing? Flip positions still fuck me up, and I've been doing this since I came out of the womb. I agree, dude. The other one I really liked is anytime we have like a minus b, that's the same thing as negative b minus a. This is like a game changer here.
Nice.
For simplifying stuff. But yeah, Diva, once we're here, we're very close, man. What do we do next? I know you got it. That's Dr. Baby Gold to you, dude. Thank you, Zach. We got Master Chief out too. Negative 27 x negative 9. Okay. So again, Diva, the negative 9 is being multiplied by x. So I want to do the opposite of multiplying by negative 9, which means I'm going to divide by negative 9. Okay? Because now this is going to go away. And now we have x is equal to negative 27 over negative 9, which is just equal to positive 3, and you're done.
Nice.
Some people say I look like Olaf, or like I act like Olaf, and like that's supposed to be me, dude. I'm like, what? No. Olaf, yeah, Olaf is here, dude. Yes, I think x equals 3 will work. Yes, very nice, yes. Did that bond coin go through? It should have, did it not? The hell? There we go. There you go, Diva. Good job. All right, let's see. Who's next up? Ethan. Oh, man, you're giving me a question with circles? Ah, shit. Ethan, what's up? You here? Oh, God. Oh, God. It's about to be bad, dude. No, dude, no. Gotta do things with concentric circles. No. No. Coral! All right, good night, dude. Good night, dude. Ethan, where you at, dude? Where's Ethan, dude? Ethan, don't leave me hanging here, dude. Your favorite. Yeah, okay, here we go. 8 circles of 2 different sizes. The circles are arranged in concentric pairs so that the centers form a square. Each larger circle touches one other larger circle and 2 smaller circles. The larger circles have radius 1. What is the radius of each smaller circle? Oh, wow. Okay. Well, Jamar, yeah, you're probably next, honestly. But, okay. We got this? This is what's going on, dude? What the hell? Yeah, at least it's not triangles. Triangles are actually my favorite. Each larger circle touches one other larger circle and two smaller circles. Okay, so for instance, this large circle, right? Oh, it touches one other large circle, right, and then it touches two other smaller circles. Okay, cool. And then we say the large circles have radius 1, and we say that this is a square. Oh, this isn't too bad, right? Well. Oh, man. Touch equals tangent. Yeah, I think touch is tangent. Yes. Yeah. I'm going to say it next time I'm on a date or something. I'll be like, can we be tangent? Can I... Tangent. Touch means tangent. Okay, so this is one. Well, I want to draw like something a little nicer. Okay. This is one, which I know. One sec. Oh, I don't like the picture of this. Yeah. I think the key thing here is that like this is going to form a square, right? And we know that all these diagonals are 1. Right? All the radius of the larger circles are 1, right? Okay, cool. And then once I can find the distance of this, then I know that these two must add up to it. How's that going to work? Oh, okay. Well, I know that, yeah, a large radius plus a small radius must equal the size of it. Okay, cool. That's how we're going to do it. Yeah, okay. All right. So, building this, I know this is 1, right? Okay, so then this distance right here must be the square root of 2. Yeah, the diagonal away. Yeah, touch me tangent. Yeah. Yeah, right. So, yeah, if this is 1 and this is 1, then this must be the square root of 2. Okay. And then I know that the square root of 2, which is a side, has to be equal to one of the large radii plus the small radii. Okay, so that's easy. All right. Yeah. Oh, so it's literally just going to be this one, right? Yeah. So because square root of 2 equals large radii plus small radii. And large radii is 1. So the small radii is square root of 2 minus 1. Okay, cool. That was pretty easy. Not too bad. Yeah, nice, dude. Nice, dude. It's actually an easy one. Okay, and then, wait, did I give Deba... Deba, are you in the tournament with us? Is Deba in the tournament? Oh, Deba's not in the tournament. Well, should be. Okay, Jamarcus may be here. Oh, here, let's do this. Taco Cat, you ready? You want to do some physics? Yeah, the diagonal was cool. Taco Cat. Yes! Okay, cool. Work and energy and power. 0 level physics. Okay. It says, boy walks up the staircase of 20 meters with a force of 600 newtons. The time taken by the boy is 8 minutes. The power consumed by the boy is this. Okay. These are some interesting physics concepts. So, what we learn is that power is equal to the work divided by the time. So if you can do a lot of work in a little amount of time, you have a lot of power.
Nice.
If you can only do so much work and it takes you a lot of time, very low power. Yes, dude. Yeah, okay. And then the other equation we have to know from physics is that work is equal to the force times the distance, okay? So the amount of force you exert on something times the amount of distance that you exert that force, that's called work. All right, monkey? That makes sense? Physics, nice. Yeah, this is decently not too difficult physics, but yeah. So the force, they say, is 600 newtons, okay? And then the distance that they climb the staircase, that's equal to 20 meters, right? So the total amount of work being done here is then going to be 12,000, is that right? Yeah, 12,000 joules is what we say. Work is done in joules. There's always that joke about, like, friction's stealing the joules or something. Physics can suck my balls. Saint. Where did physics hurt you, dude? Where on the doll did it hurt you, man? What? I think this stuff is cool. Yeah, okay. But, yeah. So this is how much work the boy had to do to climb up a 20-meter staircase, right? Physics sucks. It's hurt me everywhere. You know what they have that joke, right? Where it's like phi sucks, right? Phi sucks. Yeah. Close. Almost divided by the 8. So in physics, you need to make sure you're always using the right units for everything, okay? And when you use, that means force needs to be in newtons, distance needs to be meters, time needs to also be in seconds. What the hell happened to this stage, dude? What? Excuse me? What? Why did the stage just go away? Discord. One sec. No, I did that. There we go. We're back. Okay. Discord messes up sometimes. Yeah. So the time is 8 minutes, but I need that to be in seconds. So what I have to do is I have to take the 8 minutes. This is where we got to remember our stoichiometry, right? And I know that 1 minute is equal to 60 seconds, right? Minutes and minutes cancel. So then this is just going to be 480 seconds, okay? Yeah. So then when calculating the power, you end up getting 12,000 all over 480. Good. Yeah, very good. And then we want to know a little strategy here, okay? A second passes every second. Yeah, that is true. The other good one that's always good to know, just for conversion's sakes, is 86,400. This is how many seconds are in a day. So this number comes up a lot with things. But here, let's try to do this without, like, having to use a calculator. I think we can do it without it. 0 and 0 cancels out. So now I have 1,200 all over 48, okay? Which I could kind of see as 120 over 4.8. Which, okay. Getting closer. So I know right off the bat, right? It can't be 240. Because 240 is bigger than 120 already. It's probably not 75 either. Because 120 over 5 is... You can approximate this, right? As 120 over 5, which would be equal to 24. Okay? So, and this is just a way... If you're taking standardized tests and stuff, this helps if you're doing the SAT, the MCAT, or whatnot. This is why kids are like, oh, I can always just use a calculator. But if you can just do things quickly in your head and eliminate answers, you're going to save yourself a lot of time. So what I did here is I approximated the 4.8 as being basically just 5, and I see my answer should be basically 24. So yeah, 25 is basically what it's going to be. You can also see that, but yeah. If I divided this out straight, it would be actually 25. Yeah, process of elimination. Yes, very good. Yeah, nice. Good job. Yeah. I might have to, like, switch Olaf around with things. 'Cause now I'm starting to realize I get kind of fucking annoyed by Olaf. Like, what? Oh, man. Who was this? This was to Taco Cat. Good job, Taco. 2, 1, 2, 3. Okay, cool. All right. Don't even see requests here. Where are the other screenshots we got? Ooh, we got a lot here. All right, Nick, where you at, Nick? Yeah, we did your question because you weren't here. It's okay. It's whatever, Ethan. I'll have you. I know you do enough questions, so I'll just have you do another one at some point. Okay, where is Nick? Where is Sir Bob? Where's Sir Bob? Nice, Taco. Yeah, you're doing good. Grind. Yeah. Okay, cool. All right. Let's see. Next would be Teacup. Teacup, are you here? What did you type your question as, Anders? Can you retype it? Yeah. Yeah. It's gonna get lost in the chat. That's why I always make everyone do it here in the. There's a whole Discord channel called Help Screenshots, just so I can like kind of see like what all the questions are that we're answering. It's easier. But type it right now, and I can probably do it. Yeah. Ooh, the live command. Oh, that'd be cool. Yeah. What was your question? Is just below the screenshot of the previous question. Just below the screenshot of the previous question. Where's that? I'm looking for it. Wait, what? Where is it? As far as I understood, the inertia tensor is a way to describe each angular momentum with respect to a chosen base. Is that correct? Yes. Yeah. An axis is what it is. This is actually very cool. Yeah. Are you talking about like moments of inertia? Inertia tensor. Yeah. Oh wow, this is cool. Oh, and then the diagonal elements, I guess, are, or what we say. Okay. The diagonal are called the moments of inertia, while the rest are called the products of inertia. Oh, okay. Yeah, so the diagonals describe how much the inertia is rotating around each of the different axes, which, yes, is described as, I guess, as a basis, right? It's like what coordinate system, what coordinate frame are you in? Yeah. Yeah, no, this is pretty cool. I mean, where this comes from is, so here, if we go to like, I don't know if you've done this in like physics, but like moments of inertia table, you got this. This always like is super cool. Well, here we go. Yeah, this is actually a really good one. Yeah, so for instance, yeah, when you're rotating around like by the center of it, or if you're rotating, around the edge, or the other one they do is with the, I think it's this. Yeah. So here, one sec. So for instance, this is a cylinder, right? And the moment of inertia, if you go down the z-axis here, is going to be different than if you were rotating it, say, for instance, around like the x or y. Yeah. Oh, wow, it says currently live. Very cool, Enigma. I have to calculate one from a cylinder. The computation required is crazy. Is it that bad? I mean, if you had to do all the products, if you had to do all the moments of that inertia tensor, yeah, that would suck. But just calculating the moment of inertia of just a single thing like a cylinder, I don't think it's too bad, because it's just an integral, right, of r cross p. Or let me see. Calculating moment of inertia for a cylinder. Yeah, this is like the derivation is what it is. It's something like this. Yeah, you integrate all of like the little mass. This is actually very cool. This goes back to actually to what someone, Mikasa, asked really earlier on the stream, which is you're just adding up all the little mr squared elements around a whole cylinder. And then the radius has to be like that. Oh, the Chads thing is nice. Yeah, okay, cool. Yeah, this is a cool one. I mean, but in a physics class, you're not going to have to actually derive this. They usually give you the table here. And then anything that's like slightly different is usually just adding like an MR squared term is what it is. So the classic question is they'll give you, for instance, they'll give you a like a merry-go-round, and then they'll put someone here, and then it's rotating this way, and you want to figure out, if I add masses to this, how much does the speed change? And that comes down to what's called conservation of angular momentum, which needs to use a moment of inertia rotating around this. And so what you end up doing is you get like I for a disk, and then you can add I for like a point, which is always just going to be mr squared. And so when you're calculating the moment of inertia in this manner, you're basically doing that where you're adding mr squareds, but you're then taking the infinitesimally small differential of mass, dm, and then you're multiplying it by like that dr is what it is. I don't understand yet all the implicit assumptions to get a simpler starting point than that. Yeah, you can treat moments of inertia as a bunch of little masses that contribute mr squared to whatever your moment of inertia is. And how you add up those little mr squared then this gets into the geometry and like vector calculus of doing things. Yeah, I1 is a triple integral. Yeah, no, that makes sense. Yeah, you're integrating probably. Are you integrating like mr squared but over 3 different axes? That's probably what it is. Here, let me look it up. Yeah. So yeah, this is here for like rho is like their mass element, and then right these r squareds, x, the y squared and the z squared. That's measuring like the distance to it. Yeah, that's cool. Yeah, moment of inertia, the infinitesimally small differential unit of that inertia is mr squared. And then r then is going to take a bunch of different forms based on like what coordinates you're in. What's up, Horrific? One axis of rotation is one integral. Yeah, exactly. Yeah. But you have to like integrate over all the things. Horrific. Yeah, cool. Yeah, nice. No, that's a cool question. I like that one. That's good. Your phone's bugging? Oh, what's up, Saint? Yeah, here, Saint. Let's. Well, where's Teacup? Teacup, your question's next. Teacup, is Teacup here? I got a quiz tomorrow. Really need some help ASAP. Okay, cool. Do you wanna? Are you in our Discord yet? Yeah, post in the Discord, and then there's a channel right here called Help Screenshots. Yeah. Very good to see you, Nigma. Come back. Yeah. So here we have, it's called Help Screenshots, and then you put your screenshots in there, and then we do it. Yeah, there you go. Perfect. You figured it out. All right. Here, Saint. Let me do yours. All right. What's up, Saint? What do you need help with? Which one?
Yo, go. Just give me 1 second because my audio isn't working.
Okay, you're good. Take a sec.
I can't hear you, so I don't know what you're gonna say, but just give me a second.
Give the boy a second. Oh wait.
What are you doing? What are you doing?
Me? Just hanging around.
What are you doing? What are you doing?
Me? Just hanging around.
What are you doing? What are you doing?
Me?
Maybe I can invite him back.
Just hanging around.
What are you doing?
This is fun. Looks like we're doing multiplicities. You don't know why your audio's not working? Oh, it's okay. You can just you can type too. You can type. You can type.
Or you can't hear me? Can you not hear me? We should be able to hear me. Or you can go on the stream. A hole is 6 feet deep. How deep is the hole? Deep as your mom. Okay.
Lots of audio issues today. I had a lot of audio issues when my stream started. Actually, I had to restart my whole stream just because, like, I don't know, my mic just would not read for whatever reason. I had to restart Windows. It was annoying. Put some common area. Okay. Let's see if we can get it. Almost back to 10K channel points. Nice, dude. Wow. We got a lot here. Okay. What's up, Horrific? You want to join the stage, Horrific? The pics I sent are all the things will be on the quiz. Okay. What do you need the most help with? What's up with Discord stages today, dude? Discord's bugging out. The equations, he says. Okay, which equations? There's a lot of equations here. First screenshot. Okay, let's do it. First screenshot. I'll pull it up for you. Got it. Okay. Bum. Okay. Oh, how to evaluate this? Second screenshot. Okay. Well, to evaluate this, you just plug this in, right? Horrific, right? If here I see like 3x squared minus 2x plus 1, right? If they say when x equals -3, you just put -3 in there. Right, so it's 3 times -3 squared minus 2 times -3 plus 1. That's not too hard. What's the bed mess, dude? Why do you call it bed mess? Wait, what? Is that like PEMDAS but not? Brackets? Oh, they call it brackets. And then this is just graphing points. Same thing. You're just plugging in. What is tricky? You gotta tell me what's tricky. Maybe this is tricky. Trying to find intercepts? Dun, dun, dun. Saint, is your audio working now? Sometimes a good restart will fix it. Dun, dun. I was doing this earlier with a student. Yeah, finding intercepts is just literally whenever you have like the equation of a line, just setting either x or y equal to 0, and then figuring out what the other thing is, and that tells you it. No, that's not the reason I can't hear you. For some reason, I was able to. Oh, weird. And then once you have the intercepts here, you just connect the line between the two, and then that also gives you 2 points, which you can then use to figure out the slope, and this form y equals mx plus b. That's one way to do it. It just randomly cut out. Okay, but you can't hear me. You can't hear me at all now. What about on your phone? What about on Twitch? What about on Twitch? Is Twitch okay? We're having. Dude, is stuff down today? One sec. This is how I always check things out. Let's go to down detector. No, looking okay today. Yeah, Discord looks fine. It's about baseline. And then what's up with Twitch? Twitch is probably fine too. Yeah, Twitch about baseline too. Okay. You're confused with all the steps with how we got each answer. Okay, we'll hear it. Let's do this one first, okay? Which says, like, how to find the y-intercept. So here, they're giving you the equation of a line. 3x plus 4y is equal to 12, okay? The reason why this is called an equation of a line is because for every x, there's a y that corresponds to it, okay? Like, they call these ordered pairs. So, like, there's an x and a y that make this equation, like, valid, okay? So, for instance, if, like, x is equal to 0, right, then you just have 4y is equal to 12, which means that y would be equal to 3. So this is an example of a point on the line. We say this is an ordered pair, 0, 3. Because if I plug that in here, right, for x, and I plug this in here for y, okay, you end up getting, let's move this over, yep. You end up getting 3 times 0 plus 4 times 3, okay? This goes away. And you just get 12 is equal to 12, right? Which is good. That means this is a point that's on the line, okay? This is also, for instance, this is also going to be what's called the y-intercept, okay? Because what we learn, right, with lines, okay, and let's just say like we have like some sort of function, okay, is that wherever something crosses this axis, we call this the x-axis, right? This is called the x-intercept, okay? Wherever something crosses the y-axis, for instance, this is called the y-intercept, all right? Now, what's special about these points? So, on the x-intercept, right, where I'm hitting this x-axis, what I notice is that my y is equal to 0. Because you see here, this is y is equal to 0, right? Doesn't matter where I hit it. If I hit it here, I hit it here, I hit it here. The y there will always be equal to 0. Okay? And then for the y-axis, okay, which means where do I hit this thing anywhere, I notice that x is always equal to 0, okay? Right? No matter where I am along this axis, my x here is always equal to 0. So, when trying to find the intercepts, all you have to do is either plug in x is equal to 0, solve for y, or plug y is equal to 0 and solve for x, okay? So, we already did that here, basically. So what I did was I said, okay, cool. Let's let x equal to 0. That means this goes away, right? And I get 4y is equal to 12. Which if I divide by 4, that gets me y is equal to 3, okay? So when x equals 0, y is equal to 3. So 0, 3 is, and you can look on a graph here, right? X is 0 is over here. 3 up is here. This is going to be a y-intercept. Okay? If I want to find the x-intercept, okay, now all I have to do is say, let y equal to 0, and then solve, okay? If this is 0, that goes away, and I'm just left with 3x is equal to 12, which divide by 3, that gets me x is equal to 4, all right? So now I say, okay, cool. That means that my x-intercept is at x is equal to 4. Or you could say like 4, 0. And you look here, right? 4, 0. That's going to be an x-intercept. Okay? So there you go. So that's how you find the intercepts, which they did here, right? And then once you have those points, right? Here we have it, right? This was 0, 3. And then this is 4, 0. You could have also get what's called like the equation of the line in slope-intercept form, if you wanted to. And that's y is equal to mx, m is the slope, plus b is the y-intercept. To find the slope between these 2 points, right, you do y minus y over x minus x, which I guess becomes, what is that, negative 3/4. And then the intercept, you know, is 3. So this becomes y is equal to negative 3/4 x plus 3. Yeah. Yeah, cool. All right, here, let me do Saint's question real quick. If I have time, Horrific, I'll come back to the other ones that you need help with. But it's good to, you know, you have all the answers to all this stuff. You just have to, like, go through it, I think. Does not pass vertical line test. Yeah, all that stuff. Yeah. Okay. Saint, which one did you need help with? I wonder if I can donate MT coins to Monkey. No. No donating. The first one. Okay, cool. All right. Determine the zeros or multiplicities, the end behavior, and graph each function. Cool. All right. Zeros is just wherever this whole thing gets equal to 0. Right? Oop, I went a little too far over it. 1 sec. So what you want to do is you want to say, okay, cool. I can either have this thing equal to 0, this thing equal to 0, or I can have this thing equal to 0, right? Because if this is 0, I don't care what this stuff is. It's all going to go away. So here, determining the zeros, right? Just for x squared, that's just x is equal to 0. That's a 0. Here, this one would be x is equal to minus 5. And then this one would be x is equal to positive 6. Okay? So, do you see how that works? Do you see how if I put in 0, this whole thing goes to 0. If I plug in minus 5, this goes to 0, the whole thing goes to 0. And if I plug in positive 6, we get 0? Yes? Cool. Okay, cool. Multiplicities is what the exponent is. It's like how many times does this thing show up? So technically when we have x squared, this is really like times x, which means it has a multiplicity of 2. So this what I say is multiplicity of 2. These only happen once, so these are all multiplicities of 1. Okay. Yes, Creating Kush, I can. Join our Discord. And then we have a channel here called Help Screenshots, where if you, it's right here, Help Screenshots. Post a screenshot in there of what you need help with, and I'll see if I can get to it in the next, I think I got another like 45 minutes. Yeah, cool. Yeah, Kush. He's like, I like Kush. All right. All right, Saint. So we've got the multiplicities. End behavior. Okay. So that depends on whether the whole function is positive or the whole function, whether the whole function is even or odd. Okay. This is what I like to say. So you can either have, well, this is the other guys. So if a function is even, okay, then that means the same end behavior on left and right, okay? If it's odd, then it's different end behavior. We say opposite. And then what we also say is, okay, cool. If leading coefficient is positive, right? Then it's like this, okay? Which means positive infinity on both sides. If it's negative, then it's like this. In this case, if the leading coefficient is positive, it's like this. And if it's negative, it's like this. Yeah, cool. All right, Saint, does that make sense? So if I look at this, one way to do this would be to multiply this all the way through, which would, you know, would take some time. Like I gotta foil this, and then I gotta put an x squared on everything. But what I can also always do is just look at all the x's and just see what's happening. So I see I have an x squared, I have an x, and I have another x. So this is eventually gonna be x to the 4th. Like that's gonna be the most, like the biggest exponent I can get on x is gonna be an x to the 4th. Okay. So x to the 4th means it's even, which means it's going to be the same behavior left and right. Okay, the end behavior, yeah. So it's even, right? And then also look at the coefficients. See how this is a positive 1, positive 1, positive 1? That means positive times positive times positive, that the leading coefficient is also going to be positive, which means that, again, if the leading coefficient is positive and it's even, it means on the left and the right, it's doing this. It's infinity. It's infinity. Yeah. Dr. Gold has a hyperlink. Oh, thank you, dude. Oh, because I am Dr. Gold. That's too funny. Yeah, Dr.Gold. I tried to buy that domain. It costs way too much these days. Yeah, I wanted to get it. Someone's parking this or something. I think I go to like buy domain. One sec. I just want to like buy domain. I don't think I can get that one. Yeah. You can just DR gold. You don't have to put the period or something. That's okay. But anyways, I'm pretty sure that domain's taken. I want it. Okay. So Saint, just to like kind of to reiterate. Okay, look at this one for instance. See how I have x, x, x? This is eventually going to be an odd function because we're gonna our highest exponent will be to the 3rd on x. And then look at this. I have negative, positive, positive. So this will be negative. And so if it's odd, it means end behavior left and right is different. And because it's negative, that means it does this. And then with this one, this one's pretty odd. Well, it's technically even. But so this x squared is going to, there's like a minus x squared. Then there's going to be an x. Then there's going to be an x. So this one is going to be minus x to the 4th, which is going to be even. Right? 4's even. But because it's negative, now they're down. That makes sense? Cool. Awesome. Glad it makes sense. And then here, I'll send you the sheet for this. Wait, why is that not? Yeah, there you go. Discord's lagging today, dude. What's going on with Discord? They cut my server like randomly, dude. What the hell? Or they cut my stage. You get that? Thanks. Yeah, cool. Nice. But can I not buy the domain doctor.gold? I want to buy it. Yeah, I remember trying to buy this domain at one point. Yeah, registered in 2020. Yeah, see, someone already took this one. Can't have it. I guess I could make an offer, but they probably want like thousands. Dude, like printing things are people parking domains is like scum of the earth. I hate that. Where was horrific? Did you want me to go over your other one real quick? We still got time. Yeah, sure. Okay, cool. All right, let's do it. So, did you need this help with evaluating? Help with evaluating things? Oh, let's turn this off. Go way off. Was this what you needed help with? Yes? Okay, cool. All right, so they said evaluate 3x squared minus 2x plus 1 when x is equal to -3. All right? Not too bad. All that means is anywhere you see an x here, you need to replace it with -3. So in this case, this becomes 3 times, and I always like to use the parentheses when I put things in. All right, so this is -3 squared minus 2 times -3, right? And then plus 1. Okay? -3 squared is the same thing as +9. So this is going to be 3 times 9 minus 2 times -3 is -6. So this becomes minus 6 and then plus 1. Okay? This is 27. Minus 6 is plus 6. Plus 1. So then this just gets you 34. Okay, horrific. This is also this is a point. So this tells me on this equation of this line, let's say it's this. This is negative 3 comma 34. This is a point. It's the same thing when they go down to here, right? If you have y is equal to 3x squared, plugging in a value for x is going to get you a different value for y. So they did it here, right? Look, they just plug in 1, for instance, here. 3 times 1 squared is equal to 3. So when x is equal to 1, y is equal to 3, you can write that as a point, 1 comma 3. That's where this comes from. Yeah? Okay? Yeah. Yeah, it's not don't make it harder than it needs to be, dude. You just plug the number in and then see what you get out, and then that's a point. Yeah. Cool. All right, Nick, you want to do your question? Yeah, coming. Sorry. Yeah, well, you're here, dude. You know what the fuck? Appreciate it, brother. Yeah, you're more than welcome, dude. Yeah. Feel free. Yeah, always just drop things here. We're here. We're streaming 3 times a week. If you ever want to know what times we're streaming at, just here's the schedule. So Monday, Tuesday, Wednesday. From like 3 till 5 starting time specific. So like 6 till 8 is when we start. Hydrate. Thank you, Bill. Yes, I do need to hydrate, dude. Thank you.
Nice.
All right. I need to hydrate. Nick, where you at, dude? I got you on. Yep, you're on the stage.
Baby Dr. Gold is back. Baby Dr. Gold. Yeah, I used to have a deep voice one as well. But for some reason it would like break Discord, and I had to stop using that one. It was too much. It was too much for them. Too much. Let's see. We got that. We got Rambo. Okay, good. Oh, thank you, Ramton, for sending me that. Awesome. Sweet. Where's
QV? Where's QV? Did you create it through OBS? Yeah, I did create it through OBS. It's just it's a VST filter is all it is. I think like the baby voice works pretty well, but when I use like the low voice VST, sorry, it wouldn't break Discord. It would break OBS. Like OBS would just break. Like, that's bad. Oh, Nick says he's back now. Okay. Cool, Nick. You want to come up the stage? Nice. Okay. You can't talk though. Sorry. Okay, that's fine. All right. Find the value of x. Ooh, and we got my favorite thing, triangles. Love triangles. Okay. All right, but you can at least talk, right? You can chat. Okay, cool. You can chat. All right, great. Okay. This is actually kind of a geometry question. Yeah, thank you, dude. Where what we're gonna do is we're gonna use what are called inscribed triangles. Okay. So I have, whenever you have like triangles inside of triangles, those triangles are similar. And similar means like, kind of the same. But in geometry land, it means that the ratio of their sides are all the same between the two triangles. I want to get a Taylor Swift voice changer. They probably have some good AI stuff now these days. Yeah. Okay. So if we look at, for instance, the red triangle, I know that this whole side length right here, this is going to be 3 plus 7. This is going to be 10. And then this side is going to be x, okay? I don't know what the hypotenuse is. I could do it with Pythagorean theorem if I wanted to. Don't even start with Taylor and AI. That's a good Super Bowl game. It's pretty good. I enjoyed it. Okay. And if we look at the blue one, right? This is 7. This is x minus 3. Okay. All right. Now, what we know, she is suing everyone. Yeah, whatever. Love the lawyers. What we know about similar triangles here, Nick, is that the ratio of the sides of similar triangles are the same. So, for instance, this leg to this leg, so 10 over x, which I can write as a ratio, is also equal to this leg over this leg, which is 7 over x minus 3. Okay? I could have also done 10 to 7 is this to this. Like, teachers vary on, like, which one they want, but this one also works, okay? So then I can solve this, right, by using cross multiply. So this gets me 10x minus 3 is equal to 7x, or 10x minus 30 is equal to 7x. Which, okay, let's move the 30 over here. Let's move the 7x over here. And I get 3x is equal to 30, which means x is equal to 10. And you're done. Good job.
Well done. Well done.
Yeah, I know. Well, the whole what was it? The whole you couldn't even look up Taylor Swift on Twitter for a bit there. Nice, good. I did add a bunch of things to the stream. I did. Okay, what's up? Who do we got here? I need like this Cranium Crush. Cranium Kush. What's up, Cranium Kush? Okay, cool. Oh my god, what's going on here? Dude, excuse me. Alright, good to see you, not your friend, dude. Yeah, you're good, dude. Okay, what's the question though? Struggling to get a free bottom driving, just assuming wind is acting perpendicular to the wall. Not sure if you're needing. No, it's okay. It's all good. Here. Let's see if Cranium Crush is here to see it, or if he's on the stream. Doesn't matter if you're on the stream or if you're in Discord. Both work. Okay. Wind is acting perpendicular to the wall. Okay. So this is the wall. Okay. I got you. So like you have wind, for instance, hitting this direction. Okay. All right, we're gonna have some torsion, right? Okay. I see. And then here are some springs that are like trying to hold this thing in place. Okay. So I most definitely have the force of the wind, right? Pointing this way. Okay. And then that's going to create some sort of like, I guess we could say like rotation around here. Let's call this like our rotation point, right? Yeah, this is a statics problem, which again, I mean, I'm more of a physics guy, right? When we start getting into like pure engineering, this is where y'all start going off the deep end with like reaction moments and stuff. Yeah. Yeah. Okay. So let's think. This thing wants to move this way, but it's attached, I guess, by like some like floorboards here, which is going to end up having. We're going to have a normal force from this, right? We're going to have a force normal from here. And we should have a force normal from here. But then also we have the force of gravity. Right? Oh, there's Teacup. I was looking for you, Teacup. Where'd you go, dude? Yeah. And then what? I don't know. This force of gravity is probably like from the whole thing here. Do you do PChem? Ooh. Probably not. PChem's kind of up there, man, dude. Like, I top out at like early OChem for teaching. I'm a physics PhD, but I've tutored everything math, science up through high school for sure, and then into college, it starts getting a little fuzzy. It's especially with PChem, dude. Deflection of the plate off the surface. Yeah, this is like a specific like engineering statics question, is what it is. Is there a spot that I can see the question? I mean, well, this is just it. He just says he just wants to get the free body diagram drawn for it. Yeah, it basically just says like draw the FBD. Over here, I'll post it. I'm curious what a PChem question would look like though, dude. If you want to post one, I'm curious. I like a challenge. But here you go. Yeah, this is it. Oh yeah, you can see it now, right? Yeah. Maybe you know this, Enigma. You're in an engineering program, right? You're actually fresh on statics. I haven't taken statics in like 10 forevers, honestly. So I don't know exactly what the proper way to do this one is. Oh, you're in statics right now. Okay, cool. Do you want to do this one? I always, hand off the mic to you if you want to do this one. Wind and weight are see, these are the engineering terms, dude. Like distributed load, like what? What does that mean? Yeah, I know. I assume that means the force is like distributed amongst like different points of contact, right? Like here or here. Not the loads. Yeah. A point load in the center of the wall. Yeah, I mean that's what I said here. I said like, yeah, cool. There's just a force of wind, right? That's going to the right. I assume. Oh, you had to go to ortho? It's okay. Are you back, QV? Or are you back from the orthodontist appointment, or are you leaving to the orthodontics appointment? I remember the orthodontist. That was never any fun, dude. To the wall. Yeah, the centroid. Well, here's actually the other cool thing. I like doing this here. Let's just. What if I like Google image search this? Have you tried like Google image searching this question, dude? Oh no, that's not it. That's not what I want. No, I want this image. One sec. Work smarter, not harder. No, this hasn't been found on the internet. But we could like literally buy it if we wanted to. Yeah, where's this? Yeah, or vertical force. I agree. Well, I think of it as like the normal force of the pin, right? You know, let's see, turn off, all off. Yeah, there's definitely a force here, right, from each one of these pins. And if this thing is being pulled this way, right, that tells you that you need the net torque to be 0. So if this is going to be providing some sort of positive torque, right, or sorry, that's a negative torque, then this has to provide, right, the positive torque for it. Yeah. And then there should be gravity too, right? From I would assume that's why I would assume that the force of gravity from the plate, right? That should be distributed between these two, right? On these two pins. So maybe you can you get rid of this. And then yeah. So if this thing is trying to bend this way, right? Then what's going to happen is the quote unquote normal force, which is the force on the pins, this is going to go down by a lot, right? Whereas this one will go up. Okay. Yeah, we'll call this the left one and the right one. There is no constraint in the X direction. Okay, well, I mean, I can say this, right? I can say that there's also this. Kind of a normal force of the plate onto the pin this way, right? So there's probably there's got to be a force this way as well, right? You're right. You need the torques to be 0, but you also need the forces to add up to 0 as well. So I would say there's this, which, yeah, if those pins have that, then your free body diagram works. Yeah, it should be this. And I assume this is probably some force here, which is probably this way. You can think of it as the normal force of the pin, right? Which a lot of times when we have, the classic one is you got a ladder or something, right? Being pushed against a wall. You have a force both this way and this way. And also you have a force, both this way and this way. Or sorry, this way. It's down. Everything is gravity pointing down. The normal force is in the X. Yeah, I would just say that there is something there. It's the pin, right? Yeah, you could represent this, sure, as one force of gravity in the middle, if you want. Yeah, I agree, because it's symmetric. Yeah. Yeah. That's what I do. And then, yeah, you have a normal force on each of the pins, left and right. Oh, you can't hear me on Discord? Wait, can nobody hear me on Discord? Oh, weird. Here, QV, let me stage and opening it again. Yeah, one sec. Let me close this. Disconnect that. I don't know why that wasn't working. There we go. Okay. Now let's try that. All right, there you go. Does that work, QV? Does my voice work now? Okay. Cool. Yeah, Discord was just having issues. That helps a bit? Okay, cool. All right, I'm glad it helps. Glad it helps you, Cranium Dude. Nice. All right, QV here. Let's do yours. And Teacup, where are you at, Teacup? I've been calling for you a couple times. No, I can't. Now I can think. Okay. All right. Here, did you want to... Okay. I wanted to know when a substance is nonpolar or polar ionic solute, and it predicts how it dissolves in water, and a little bit on IMS, so intramolecular forces. Okay, cool. All right. Oh, this is what you have. It looks like this. Is this the table? I did this, but a copy from somebody else. Okay, yeah, that's okay. It's okay. It's okay. All right. All right. Okay. So anytime on a periodic table, if you have something from here bonding with something like from over here, this is going to make it ionic. Okay. So in the case of NaCl, right, you got Na over here, you got Cl over here. That's an ionic compound. And then whether it's, I think ionics are always polar. I don't think you ever have things, wait, can you? Okay. Yeah, the only difference is if they're the same thing. This I don't think is ionic, though. No, this is not ionic. So ionic is when you have something from the left and something from the right. If both of these things are on the right, then that's going to be covalent. What if there are multiple things bonding? Yeah, okay. So, what if there are... Right, and then this is, yeah, okay, for a Lewis structure, right? Na does not bond to Cl like this. No. Na gives up all of its electrons, and chlorine takes it, is what happens. So NaCl really just looks like this. It looks like Na plus Cl minus. Yeah, that's the resulting final ions, is what we say. So whenever you have something from here with here, it's ionic. They break up into whatever their ions are. Okay. Silicon dioxide, however, yeah, this is correct for drawing it. You have no audio. Oh, okay. What's wrong with your audio, dude? What? How can I teach you if you have no audio? I can't teach you if you have no audio. I don't do Braille. Okay, one sec. Was it silicon dioxide? Yeah. Okay. Yeah, so in the case where you have multiple things bonding, I mean, hopefully it's all things, over here, if it's multiples, which I think it is in this case, right? So for silicon dioxide, right? Silicon is like over here, I think, or something, or somewhere down there. And oxygen's up here. This is going to be covalent, right? This is a covalent bond. Okay, so when they say, would it be considered nonpolar or polar ionic solutes? that you have to look at what the geometry of it is, okay? In this case, this thing is symmetric, right? You learn from, where was it? The different, was it molecular geometries? Was it this? There we go. Okay. So when we have this, okay, the things that are polar are this. This is polar. This is gonna be polar. This is gonna be polar. Actually, here, let me just make the things that are non-polar. Here, this is non-polar. I think all of these are actually non-polar. These are all non-polar. And then this one's non-polar. And this one's non-polar. Is this one non-polar? I think it is. Okay. And that's assuming that whatever the X things are all the same. They have to all be the same thing. That's what they have to be in order for it to be non-polar. So looking at silicon dioxide, right? This is something with just two things on it like that. That's linear. Linear means that it's non-polar. Okay. So this I would say is non-polar. Yeah, anytime you have like three different things or whatnot, this is 100% going to be polar. In order for something to be non-polar, you need like nice symmetry. You need things to be balanced. And that's very hard to get when you have three different things. So like, yeah, this is polar. This is just by itself, right? This is just chilling. So I don't know. If it's just chilling by itself, doesn't that that's just aluminum, right? I think it's aluminum 2+ is what it is technically. And then CH4 here. And then yeah, O2, right? Yeah. This is also nonpolar because it's two things. NH3, this is going to be polar because you have a lone pair there. Right, hydrogen bonding because it's HN. And then this one looks like this. It's like almost this one. Actually, this one I think is what you should have drawn for here. And then this one is nonpolar. Because it's one of the nice balanced shapes. It becomes which one is it? It's this one. It's the tetrahedral. Right. So if you have more than two things bonding, it's most definitely going to be polar. If you have more than two different things. In the case of, like, for instance, silicon dioxide here, all the things bonding to the silicon are the same thing. They're all oxygens. So that's what allows it to be symmetrical and then have it be nonpolar. In terms of what are the solutes? Okay. Okay. Solutes has to do with when something is dissolved in water, how it dissolves basically. Okay. So yeah, maybe you've learned this. So like a solution has what's called a solvent and a solute, okay? This is usually water, okay? And then this is the substance. Okay? Certain things in water will dissolve into what we call like their ions. So NaCl, for instance, well, I'd set it right here, right? NaCl, when it's in H2O, like if it's aqueous, will just dissolve into sodium ions and chlorine ions because it's what is that? It's polar because it's an ionic solute. I don't think they want you to say polar or ionic. I think they want you to say like ionic or polar. I don't think it's polar and ionic. Let me see that. Ionic or polar solutes dissolve in pulver. I was like that on. It was like that. Yeah, but I think it's one or the other. I don't think it's both. Mm-hmm. Let's see, polar versus. I mean, uh-huh. Solutions with ionic and polar. Is it ionic and polar or ionic or polar? This was the key? Okay, cool. Yeah, let me see. Okay. There we go. Oh, I see. Yeah, okay. So look here, QV. So, right? Yeah. Just because it's polar doesn't mean it's also ionic. If it is ionic, it's definitely going to be polar, though. Okay? Does that kind of make sense? Like all cats are animals, but not all animals are cats. Yeah, right? So look here, for instance, this thing is polar. I agree it's polar because you have different stuff attached to it, but it's not ionic. Ionic, again, is when you have something from the left side of the periodic table with the right side of the periodic table. And notice when you draw your Lewis structure, they're not bonded because they don't share electrons. What happens is sodium loses an electron. It gets rid of it and becomes a positive ion, whereas chlorine gains an electron and becomes a negative ion, okay? That's why this is ionic. And that's why these are the final ions. The same thing as I wrote here, right? Where it's Na plus and Cl minus. That's the same thing here. Yeah. Right. Polar compounds do dissolve in water. That's just true. So anytime it's polar, yes, dissolves in water. And I guess nonpolar don't, which kind of goes back to, where was it? Where's that image we had here? Yeah, whoever this was, Dr. V or something, was this person? Right? Because they say, like, solute particles, okay, interact with the particles of the solvent. Remember what I was talking about? How a solution is a solute and a solvent. Solvent is like the water. It's the thing that dissolves stuff. Solute are the particles. It's like the grains, like the salts, okay? So in this case, with NaCl, right, you have a bunch of Na positives, that's the positive stuff, with the Cl minuses, and it makes a crystalline structure. In this case, it's salt, like a salt crystal. And the H2O, which is the water, that is the solvent, interacts with the individual ions here to pull them off, right? So it pulls the Na and the Cls away from each other, such that now they exist by themselves as solvents. And this is very cool. Actually, I like this diagram because it has to do with the polarity, right? Because this thing is negative, right? It's attracted to the positive H's in H2O, right? In H2O, water is polarized in this direction, right? Where there's more negative here and there's more positive here. But for instance, Na, which is positive, is going to be attracted to the negative part, the negative polarity part of the water, which is the H2O. And so, yeah, that's pretty cool. Okay. So, yeah, so in general, in order for something to dissolve, you need it to be polar, because that's the only way that that's the only way that a solvent can pull it off. Is there a covalent solute? Yes. Yeah, you can have that for sure. Yeah. I mean, this is, yeah, this is, so she just put no. Would it be considered non-polar? I think this is non-polar is what she's meaning to say, right? I think she means to say non-polar. I don't know why she just put no. Or maybe, ooh, okay, wait. Silicon dioxide solute. Oh, it's a crystal. So yeah, why can't it be a solute? It's not soluble in water. Oh, okay. Okay. Oh, I see. Okay. Yeah, it's kind of weird. But yeah. Does this all make sense? I gotta go here pretty soon. Yeah? Cool. All right, good. Good question, dude.
Well done! Well done!
All right. Okay, I think I got to everyone here today. There's so many questions today. Yeah. Okay, good. Awesome. Okay, cool. All right, awesome. All right. Thank you, everyone, for coming to office hours today. Had a really fun time answering all your questions and stuff. You still want to ask more questions? We're going to be here all week. So Tuesday, Wednesday, all at different times. You can find them out on... Is that... It's Jake Gyllenhaal. Anyways, there's our schedule. Thank you again to all our top subscribers. I really appreciate you guys. You keep the server going. All our Discord boosters. You keep us with the level 3. Appreciate it too. WStream. Yes. Awesome. Okay. Nice. Okay. I'm going to go teach another student pretty soon here. But... Let's have you all raid another channel to get some points. So let's see, who are we gonna raid? Who's doing it? Dawn's doing DayZ. Do you guys want to go to science or paleontology? Where do you want to go? Yes, I know. Yeah, all the tech companies are allowed. Yeah, they get away from not being able to pay taxes. I agree with. Yes. What about that, Bob Ross's? What do you want to say? Pitbull says paleontology has science. Here, do we want to roll a dice? You want to roll a dice on it? Here, let's roll dice. How are they able to get out of them? Because they carry forward their losses, is what they do. I'm not a CPA, so I can't tell you exactly. But basically, what like Amazon and Microsoft and all these companies do is they write off all the money they spend on, like, for instance, buying warehouses or buying trucks, or they buy a bunch of stuff ahead of time. They write it off as a loss, and then they don't have to pay taxes on it. Yeah, it's fucked up, but that's what they do. Okay, so science or paleontology. Okay, here we go. We're gonna spin. No, we're not. No, I'm just I'm telling you guys where we're gonna go. Where we're gonna go. We're going to paleontology. Okay. Cool. All right, go say hi to the paleontology people for me. He's a fun guy. He's probably, honestly, on the science stream anyways. But okay. Head on over. We will be back tomorrow. That's going to be 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on over. I will see you guys tomorrow. Enjoy the rest of your Monday. Hope it's great.
That's dope.
Peace.
Discord. It's looking really, really cool.
Education. Thank you for the raid. Welcome to Paleontologizing.
Education and their 19 raiders are about to get flattened by dinosaur content.
Actual Education, thank you so much for the 19 viewer raid. How did your stream go, Actual Education? It is an honor and a privilege to have you here. Tell me about how your stream went. I hope it was really, really good. Yeah, an Infamous Teacup. How are you doing? Welcome, welcome, Infamous Teacup. That's not Russell's teacup, is it? And a Ms. Monkey, how are you doing? Welcome, welcome. Thank you for coming in on the raid. How are you doing? Welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist.
Nice.
Dinosaurs are what I work on, what I study, what I publish on. And, I don't know why that light got turned off, but...
There are fewer than 40 full-time dinosaur paleontologists.
Ironbark. Thank you, thank you. Holy cow.
3 of them are leading this expedition.
Thank you for those 5 gift subs there, Ironbark. I really do appreciate that.
Ironbark 72 just gifted.
Thank you, Ironbark. Actual Education, I hope you had a wonderful stream. It's great to have you here. We're talking about old Chucky D today. Old Charlie Darwin. Charles Darwin. As you might be able to guess, looking at my background today. The influence of this idea of natural selection, evolution, a kind of naturalistic view of natural history. If that's not actual education, I'm not sure what is. So I appreciate you rating in. I hope this is right up your alley. It seems like it is. Yeah. And is Nigersaurus real? It is. I have a pit bull. Nigersaurus is a real dinosaur. It's a weirdo, but it's definitely real. Yeah. It's a kind of, I think, Dicraeosaurid sauropod. It's got a pretty weird mouth, but you know what? The